So remember, we've been taking quadratic expressions like this and factoring them, breaking them down into two expressions that multiply together to make the original. And we've been using pictures. So we're saying this is an x squared, these are x's, and these are 1's. And I've been telling you to make them into a rectangle. So we have an x squared in this case. We would have 4x's this way, 1 this way, and then the 4 1's would go right here. And based off that rectangle, we could say, well, this has a length of x plus 4, and this has a length of x plus 1, okay, and it would be a quilt. And we could say the area for that quilt then is the regular x amount plus 4 inches times the other x amount plus 1 inch. We've been doing it with pluses or positive numbers because that makes the most sense in the real world and it's easiest to do. But in this task, we can also show how it can be done with negatives. So now the Optimus Quilt is accepting orders for rectangular blocks. Their business is growing by leaps and bounds. Many customers want rectangular blocks that are bigger than the standard block on one side. That's the plus we've been doing. But sometimes they want one side of the block to be the standard length x, with the other side of the block to be bigger. Color in blue pieces that are added and red pieces that are subtracted. So ignore all the little lines. This just helped the person draw this. This is the standard quilt x squared. And they wanted one side to stay x, but they wanted to add 2 inches on the other side. So this side becomes an x length plus 2. And if you were to write it in factored form, you'd say the area for this quilt is x length times width, or width times length, x times x plus 2. And then you could say, well, that would be the same as an x squared block plus 1, 2 plus 2x blocks. And that would be the same thing you would get if you distribute it. Sometimes they want one side that is the standard length x and one side that is 2 inches less. So they actually want it to be skinnier. So here you go. Here's our standard x squared block that she starts with, a fabric. She wants this side to stay x, but she actually wants, whoever's ordering this, wants this side, wants them to cut off 2 inches, 1 inch, 2 inch. So really, it's like this is going away. Well, if it went away, then this side is x, excuse me, minus 2. So the new area would be x times x minus 2, which would turn into x squared minus 2x's. So it does work if you have negatives. It's just kind of harder to think about. And often when I was showing you in class, I would call these just negative x's so you could still see the pieces. But technically, we're cutting that fabric off. All right, there are many other size blocks requested, with the side lengths all based on the standard length x. Draw and label each of the following blocks. Use your diagram to write 2 equivalent expressions for the area. Okay, one side is 1 inch less than the standard side, and the other is 2 inches more. So here's our regular standard x squared, block to start with. And then she gets the order and she's told to cut off 1 inch. So this part is gone. So that's x minus 1 inch. But she's told to add 2 inches on this side. Okay, so that's x plus 2. And notice when you do that, this one is subtracting 1 inch. This one is adding 1 inch. So really, you only added 1x or 1 inch or whatever the x is to it. And then in order to complete a full shape, you're kind of missing 2 little ones. So if you were to write this down, you'd say a of x, the area of the new quilt, is this part, the width, x minus 1 times the length, x plus 2. And if you were to multiply it out, you'd get x squared plus 2x minus 1x minus 2, which would simplify to x squared plus 1x minus 2. Or if you look at the picture, okay, here's our x squared plus 1x, but minus the 2 pieces, because really that's what we're left over with. All right, we're going to skip all of these and just kind of look at what happens when we have different combinations of subtracting and adding amounts. So remember, we start with ax squared plus bx plus c. That's our standard quadratic. And we've just been doing one quilt, so our a has been 1. And we've been trying to figure out what multiplies to make this number, but adds to make this number. And that's what was filling in right here, if you remember correctly. So if you go back up and look at number 1, right, we'd wanted what multiplied to make 4. Well, 4 times 1 is 4, but added to make 5. 4 plus 1 is 5, and that would give us the rectangle. We learned that last time. So what I want you to see is, if you're adding to both sides, then this middle amount is positive and the c amount is positive. If you're subtracting from both sides, the middle amount is negative, but the c amount is positive. If you have one of each, the c is always negative, but the middle depends on which one of these numbers is bigger. Since 3 is bigger than 2, the middle is negative. Here, 3 is the positive number. It's, again, bigger than 2, so the middle is positive. And that pattern can help you out. All right, let's just go down here. There's another pattern we can think about. We talked about before, what if you had something like x squared minus 9, and we wanted you to factor it? Well, I told you, you could just say, well, that's 0 x's. They didn't necessarily add any x's in the middle. Minus 9, and then we'd figure out what multiplied to make 9, but added to make 0, and it'd turn out that it was x plus 3 and x minus 3. So this one right here. Okay, if you were to look at that picture, we have our x, and on one side we're adding 3, 1, 2, 3, but on the other side we're subtracting 3, 1, 2, 3. Okay, and what we're left with is this part. Okay, and this minus 9, because this x is negative, this x is positive, and it cancels out. Negative, positive, negative, positive. And we basically are missing 9 in the end to finish our rectangle. So what I want to show you is basically, if there's no 0x, this is the picture for it, we don't really care. You can either add a 0 in the middle and then figure out what multiplies to make negative 9 and adds to make 0, or you can look at this pattern, which is if you have something squared minus something squared, it turns into, I'm going to call this an x, the square root of the first thing, so square root of x squared is x, and the square root of the second thing, square root of 9 is 3, and you would just do plus and minus, and we did talk about this in your homework before. Finally, let's try some of these without the picture. So if you look at this one, we want to figure out what's a times c. Remember, this is ax squared plus bx plus c. We've always just said what multiplies to make this and adds to make this, but really it's what multiplies to make this number times this number. We just haven't talked about it because for all of our problems so far, this number's been 1, and 1 times 18 is still just 18. But if you think about it, 1 times 18 is 18. We need what multiplies to make 18, so that's what this table is using our little chart. And of those numbers, how could we add to get a positive 9? And it turns out it's 6 plus 3. And since this number is 1, that means we're done. Our answer is x plus 6 and x plus 3. Let's try the next one. We need what multiplies to make 1 times negative 18. So that's negative 18. And we're going to list our factors from our chart, 1 and 18, 2 and 9, 3 and 6. This time I need it to be a negative 18, so if I think about it carefully, it's still going to be 3 and 6, but this one has to be negative. Let's see. 3 times negative 6 is negative 18. That worked. And I want it to add, oh, I did it backwards. I want it to add to be a positive 3, so this one has to be negative. Remember, it keeps the sign of whichever number is bigger, and I wanted it to be a positive 3. So let's check it again. Negative 3 times 6 is negative 18. Negative 3 plus 6 is positive 3. Please use your calculator to check this so you don't mess up with a sign error, which then means the answer is x minus 3 and x plus 6. And again, what I wanted to show you on this one is you get the same thing, but when you're doing it, this time, it was what I had on the error before, now the 6 has to be negative to make this a negative 3. So it would be x plus 3, x minus 6. All right, you're good to go with your homework.